Welcome to our channel Learning Math. In this video, we're going to solve the Math Official Exam second session for 2021 for life science students. Now let's start together by the first question. As you see here, we have to choose the correct answer. The inequality ln x less than 1 is verified for what values of x? Let's see together. Note that we have ln x less than 1. Can't we say in this case that exponential ln x is less than exponential 1? Well, note something, we need x. We interpret the exponential function to get x since the exponential function is the inverse to logarithmic function. This is the first reason. The second one is that exponential is an increasing function, so we can say that ln x less than 1, it gives us exponential ln x is less than exponential 1. Well, exponential ln x, isn't it x? Since exponential and logarithmic functions are inverse functions to each other. So x is less than exponential 1, so we can say that x is less than a. But note something which is very important. We have the logarithmic function is defined on positive regions, so we have to say that x is positive. Therefore, 0 is less than x less than a. The equation ln square x plus ln x minus 6 equals 0 has two roots, x1 and x2. Now let's find the product of these two roots, x1 and x2. If you note something, we have ln square x plus ln x minus 6. If we take capital X equal ln small x, can't we say in this case that x squared plus x minus 6 equals 0? Isn't it a quadratic equation? If we solve this quadratic equation, then we can get the solution. Here, as you see, we can say that delta is b squared minus 4ac, b is 1, a is 1, and c is minus 6. Well, so it's 1 plus 24, it gives us 25. Now we can find the roots, x1 which is minus b minus radical delta over 2a, b which is 1, radical delta, radical 25 is 5 over 2a, a is 1, so it's over 2. Then it's minus 6 over 2, it gives us minus 3. The second root x2 is minus b plus radical delta over 2a. Also we solve it to get x2 equal 2. But note we have just taken that x equal ln small x. So for x1 equals minus 3, we can say that ln small x1 is equal to minus 3. So we can say that x1 is equal to exponential minus 3. This is the first root. What about the second? Also we have x2 equals 2. But we have x equal ln small x. So we can say that ln x2 small is equal to, then x2 is equal exponential 2. Now we can calculate the product of x1 and x2. It's exponential minus 3 times exponential 2. It gives us exponential minus 1. Since minus 3 plus 2 is minus 1. Now find the limit as x tends to plus infinity for x plus ln x over x all plus 1. Note something which is very important. Here we can say that it's equal to limit as x tends to plus infinity for x plus ln x over x all plus 1. But if we think about this limit, here x tends to plus infinity. Also ln x tends to plus infinity. Also x tends to plus infinity. Infinity over infinity is indeterminate, then we should use Lopita Rule. Then we can say that this limit is equal to the limit of the derivative of the numerator over the derivative of the denominator. We can apply here Lopita Rule since we are having a fraction with indeterminate limit. Well, the derivative of the numerator, u prime plus v prime, so it's 1 plus 1 over x over the derivative of the denominator which is 1. Well, so here every numerator over 1 remains the same, so it's 1 plus 1 over x. 1 over x tends to 0 as x tends to plus infinity. Here 1, we copy it, plus 0 plus 1, then the limit is 1 plus 1 is equal to. A security entrance keyboard for a building is formed of 3 letters A, B, and C and 5 digits from 1 to 5. The entrance code is formed of one letter followed by a number of 3 digits. Well, One letter, this letter can be 1 out of 3. It can be A, B, or C. So we say it's combination 1 out of 3. Then we should choose 3 digits, a number formed of 3 digits. So we choose 3 digits out of the 5 given digits. We say it's combination 3 out of 5. So it's C1 3 times C3 5, but not something which is very important. We can permutate or change the arrangement of these 3 digits. So here it's a 3 factorial cases. So we should multiply it also by 3 factorial, then it gives us 180. Well, now let's start by the second exercise. We have an air new that contains red and black balls holding distinct natural numbers. 60% of the balls are red, of which 80% of them hold odd numbers, while 70% of the black balls hold odd numbers. Before solving this question, we should analyze the given. Well, 60% of the balls are red, then 40% of them are black. Well, now out of the red balls, we have 80% carry odd numbers, then 20% carry even numbers. While out of the black balls, we have 70% carry odd numbers, then 30% carry even numbers. Now let R be the event that the selected ball is red. We should select one ball from this urn, and O be the event that the selected ball carries an odd number. Show that the probability of P of O intersection R is 0.48 and calculate P of O intersection R bar. Note something, 60%, doesn't it mean 60 out of 100? So a 0.6 is 60 over 100. Also 80% is 80 out of 100. 80 over 100, it gives us 0.8. Well, P of O intersection R, isn't it 0.6 times 0.8? So we can say it's equal 0.48. Now we need to calculate P of O intersection R bar. What does it mean P of O intersection R bar? The ball shouldn't be red, R bar, so it should be black. We are still having a ball carrying odd number, but it's a black ball. So here we should calculate the probability P of O intersection B, which is R bar. Well, isn't it 0.7 times 0.4? So it gives us 0.28. Now calculate P of O. Isn't it P of O intersection R plus P of O intersection R bar? We have just calculated both of them. So it's 0.48 plus 0.28. It gives us 0.76. Now are the two events R and O independent? Justify your answer. Note something, if we calculate P of O times P of R, isn't it 0.76 times 0.6? We have the probability P of O, we have just calculated it. P of R is 0.6 since we have 60% red balls, 60 out of 100, so it's 0.6. Well, as you see, the product is 0.456. It's completely different from P of O intersection R. We have just calculated it. Therefore, P of O intersection R is 0.48, different from 0.456. Therefore, the events O and R are not independent, they are dependent. Well, in part B, suppose in this part that the number of balls in the urn is 50. Show that the number of red balls holding odd numbers is equal to 24. Well, we have 50 balls. 60% of them are red. 60% of what? Of the 50 balls. So it's 0.6 times 50. It gives us 30. Note that the total number of red balls is 30. Now what about the red balls that carry odd numbers? Aren't they 80% of the given red balls? So they are 80% of the 30 red balls that carry odd numbers. 80% means 80 out of 100, so it's 80 over 100 gives us 0.8 of means times 30. 0.8 times 30, it gives us 24. So there are 24 red balls that carry odd numbers. Now copy and complete the following table. Note something, we have 30 red balls. If 24 of them carry odd numbers, then the remaining 6 will carry even numbers. Also, if we think about it, 20% of the red balls, so 20% of 30 carry even numbers, so it's 0.2 times 30, it gives us 6. Now what about the black balls? Isn't the number of black balls 50 in all minus the 30 red, which gives us 20? Or we can say 40% of all balls, which are 40% of 50, is 0.4 times 50. It gives us 20 black balls. Well, aren't 70% of the black balls carrying odd numbers? So they are 70% of 20. The number of black balls is 20. So 70% of 20, which is equal 0.7 times 20 equal 14. 14 black balls carry odd numbers. The remaining from 14 to 20 are 6. They should carry even numbers, or we can say 30% of 20, which is equal to 6. Now the total number of balls carrying even numbers, as you see, 6 plus 6 equals 12. Note here to check up our answers, 24 plus 14 equals 38. The total number of balls, black and red, that carry odd numbers is 38. Now calculate the probability of selecting at least one red ball holding an odd number. Note that we select 3 balls randomly and simultaneously from the air new. Now what's the probability of selecting at least one red ball with an odd number? Probability of selecting at least one red ball with an odd number is 1 minus the probability of not selecting any red ball with an odd number. Note something. The number of red balls that carry odd numbers is 24. If we did not select any red ball carrying an odd number, then the 3 balls that we have selected should be from the remaining 26 of 50. Since 50 balls minus 24 gives us 26. So we should write it 1 minus combination 3 out of these 26, since we select 3, from the remaining which are not red carrying odd numbers. So it's 1 minus C3 26 over C3 50, since they are in all 50 balls. So it's equal 85 over 98. Now the even numbered balls hold the numbers from 2 till 24. So they are in all, their number is 24 divided by 2 equal 12. We have 12 even numbers. Knowing that the 3 selected balls hold even numbers, so they are given even. Calculate the probability that each of these balls holds a number greater than 50. Well, if we think about it, we have the even numbers are from 2 till 24. So the number of balls carrying even number is 24 divided by 2 to know the even numbers between them. So it's equal 12. We have chosen 3 out of these 12 even numbers. But what's the probability that we have chosen them greater than 15? If you know something, the even numbers that are greater than 15 are 16, 18, 20, 22, and 24. So they are 5 numbers, 5 even numbers greater than 15. What's the probability of choosing the 3 balls from these 5 numbers out of the 12? Isn't it combination 3 from 5 over combination 3 from 12? So it's 1 over 22. Now let's start by functions. The plane is referred to an orthonormal system OIJ. Consider the function f defined on R as f of x equals 2x exponential minus x plus 1 all plus 1. Denote by C its representative curve and D the line with equation y equal 1. Now determine the limit of f of x as x tends to minus infinity. Well, note that as x tends to minus infinity, we have x will tend to minus infinity. While here minus x will tend to plus infinity, so minus x plus 1 will tend to plus infinity. Then exponential minus x plus 1 will tend to plus infinity. Well, plus infinity times minus infinity, it gives us minus infinity. Minus infinity plus 1, it remains minus infinity. So the limit of f of x as x tends to minus infinity is minus infinity. Now show that limit as x tends to plus infinity for f of x is equal to 1, then deduce that d is an asymptote to the curve C. What about limit for f of x as x tends to plus infinity? Isn't it the limit for f of x here for 2x exponential minus x plus 1 as x tends to plus infinity? Note that minus x will tend to minus infinity. Here minus infinity plus 1 is minus infinity. Well, exponential minus infinity, isn't it 0? Well, here x tends to plus infinity times 0 is indeterminate. Well, here we cannot apply Lopita rule. But if you know something, we can transform it into a fraction and then apply Lopita rule. We have a rule that exponential minus a is equal to 1 over exponential a. Well, what about exponential minus x plus 1? Isn't it exponential? Take minus as a common factor. What remains? X minus 1. Since we have here plus is minus times minus. Then we can write it as 1 over exponential x minus 1. So its limit as x tends to plus infinity for 2x which remains on the numerator over exponential x minus 1. Sure, all plus 1 will not affect this limit. We add it at the end. Now let's start by applying Lopita rule. The derivative of the numerator 2x is 2 over the derivative of the denominator exponential x minus 1 is exponential x minus 1. Now if we think about it, what's the limit as x tends to plus infinity for exponential x minus 1? Isn't it plus infinity? Here x minus 1 will tend to plus infinity, exponential plus infinity is plus infinity. Well, what about 2 over plus infinity? Isn't it 0? Plus 1 we copy it. Well, 0 plus 1, 0 plus 1, isn't it 1? So the limit for f of x as x tends to plus infinity is 1. Now deduce that d is an asymptote to c. So here we should calculate limit as x tends to plus infinity for f of x minus yd which is 1. Well, if you know something, f of x minus 1 is 2x exponential minus x plus 1, we can apply Lopita rule as what is explained previously. So it will be 0. Then we can say that d is an asymptote to c. By another method, we have calculated limit as x tends to plus infinity for f of x which is 1. Then we can write this limit is equal to 1 minus 1 is equal to 0. So we can conclude that d is an asymptote to c at plus infinity. Now show that f prime of x equals 2 into 1 minus x exponential minus x plus 1 and copy and complete the table of variation. If you know something, we have f of x equals 2x exponential minus x plus 1 all plus 1. Well, what about the derivative of this function? If you know something, the derivative of the constant 1 will be sure 0. What about this derivative for 2x exponential minus x plus 1? Isn't it in the form of u v prime? So it will be u prime v plus v prime u. Let's start by this derivative. The derivative of 2x, isn't it 2? E minus x plus 1, we copy it the same. So it's u prime v plus, we should write it now v prime u. U which is 2x, we copy it the same. What about v prime? The derivative for exponential u, isn't it u prime eu? Well, here u is minus x plus 1. What's the derivative of minus x plus 1? Isn't it minus 1? Well, so it's minus 1. EU, we copy it exponential minus x plus 1 the same. Sure, plus 0, the derivative of 1 is 0. Well, now we just calculate them. So it's 2 exponential minus x plus 1. Here, plus times minus, minus 1 times 2x, it will be 2x. Exponential minus x plus 1, we copy it. Plus 0, it doesn't affect. Now we can take here, if you know something, 2 exponential x minus 1 is common on both terms. So we can take 2 exponential minus x plus 1. What remains here? Nothing, which is 1. Minus, we copy it. What remains here? X. So it's 2 into 1 minus x exponential minus x plus 1. Now if we think about a local maximum or minimum for f. What? Shouldn't we solve f prime of x equals 0? What? You know that exponential minus x plus 1 or exponential for any function u will be positive for every value of u. Also 2 is different from 0. Then f prime of x will be 0 only if 1 minus x equals 0. So x equals 1. Now let's complete the table of variations. If you know something, for x less than 1, then 1 minus x will be positive. Here 2 is positive. Also exponential minus x plus 1 is positive. So f prime of x in all will be positive. While if x greater than 1, 1 minus x will be negative. The sign of f prime of x depends on the sign of 1 minus x, since 2 exponential minus x plus 1 is positive. So plus times minus will be minus. Then here for x greater than 1, f prime of x will be negative. Now what about f of x? Sure, for x equal 1, f prime of x is 0. We have just proved it. Now for f prime of x positive, f of x will be increasing. For f prime of x negative, f of x will be decreasing. Now what about the limits? As x tends to minus infinity, we have f of x tends to minus infinity. Now for x equal 1, f of 1 we have it equal 3. Also then f will be decreasing from 3 till limit at plus infinity for f of x, which is 1. Now show that the equation f of x equals 0 has on R a unique solution alpha. Let's prove it together. If you know something, on the interval minus infinity 1, we have f of x is continuous and it's also strictly increasing. It's a monotone here. So f is continuous and strictly increasing from minus infinity, which is negative, to 3, which is positive. Then we can say that f will admit a unique solution on the interval minus infinity 1. What about the second interval 1 plus infinity? Actually here f is continuous and strictly decreasing, but it decreases from 3, which is positive, to 1, which is also positive. So here we cannot say that it will admit a root on the interval 1 plus infinity. Therefore, we can say that f admits a unique root, f of x equals 0. It has a unique solution which will be on the interval minus infinity 1. So f of x equals 0 admits a unique solution on R. Now verify that this solution alpha is between minus 0.16 and minus 0.50. If you know something, f of minus 0.16 times f of minus 0.15 is minus 0.02 times 0.05. It's approximately minus 0.001, which is negative. We can either prove it in this way, the product of their images is negative, or we can say that f of minus 0.16 is negative and f of minus 0.15 is 0.05, which is positive. Therefore, we can say that alpha is between minus 0.16 and minus 0.50. Now calculate f of minus 0.5 and f of 0, then draw C and D. F of x equals 2x exponential minus x plus 1 all plus 1. Now let's calculate f of minus 0.5, which is minus 2 times 0.5, which is 1, exponential minus times minus plus 0.5 plus 1, it will be 1.5, all plus 1 is approximately minus 3.481. Now what about f of 0? We just replace x by 0. Sorry, so it will be here 0. Here 0 plus 1 is equal to 1. Now let's start drawing the curve C and the straight line D. If you note here, we have the straight line D of equation y equal 1. What about the curve C? When x tends to minus infinity, its limit will be minus infinity. It increases. Well, here we have the root alpha. This function at f of 0 for x equals 0, it's 1. It increases till here for x equal 1, since we have f prime of 1 equals 0, f of 1 equal 3, it increases to 3, and then it will decrease as x tends to plus infinity, f of x tends to 1. Well, here we have y equal 1 is a horizontal asymptote, as you see, to this function at plus infinity. Now show that integral x exponential minus x plus 1 dx is equal to minus x minus 1 exponential minus x plus 1 plus k, where k is a real number. Here we can prove it in two methods. First, we can prove that the derivative of minus x minus 1 exponential minus x plus 1 plus k will be equal to x exponential minus x plus 1. Or we can solve this integral to get the answer minus x minus 1 exponential minus x plus 1 plus the constant k. Well, let's start by the first method. If you note something here, if we solve the derivative of this function, is in the form of uv prime, it will be u prime v plus v prime u. So u prime, which is minus x minus 1 prime, v, we write it, plus v prime, which is the derivative of exponential minus x plus 1 is prime, times u, which is minus x minus 1, we copy it, plus the derivative of k, which is 0. Now let's solve the derivatives here. The derivative of minus x minus 1 is minus 1 times exponential minus x plus 1, we copy it the same, plus here minus x minus 1, we also copy it the same. Now we solve the derivative of exponential minus x plus 1. EU prime is u prime, EU you know is, so the derivative of minus x plus 1 is minus 1, exponential minus x plus 1, we copy it the same. Now if we multiply minus times minus plus, also here minus times minus plus, then it will be minus 1 plus x plus 1 all multiplied by exponential minus x plus 1. Note that minus 1 plus 1 cancelled, so it's equal x exponential minus x plus 1. What about solving it using integration by parts? If we take here u equal x, then du equals dx. If we take dv equals exponential minus x plus 1 dx, what about v? Note that the derivative of exponential minus x plus 1 is minus exponential minus x plus 1. So when we have dv is exponential minus x plus 1, then v will be minus exponential minus x plus 1. We multiply here by minus. Well, to solve this integration by part is u times v minus integral v u. U times v is minus x exponential minus x plus 1 minus integral v du. Well, what about integral v du? Is integral minus exponential minus x plus 1 du, which is dx. Well, its integral is clear here. It's directly we can write it exponential minus x plus 1 sure plus k, where k belongs to r. Well, now if you know something, exponential minus x plus 1 is common on both terms. We can take it as a common factor. What remains here? Minus x, here minus, there's nothing, so it's 1. Minus x minus 1. Now deduce the area limited by the curve C, the straight line with equation y equal 3, and the two lines with equations x equals 0 and x equal 4. Well, note something, here is the shaded area that we should solve. The straight line of equation y equal 3 is above the curve C. So if we think about this area, it will be 3 minus f of x. Well, its integral from 0 to 4 for 3 minus f of x. We just replace f of x by its value to calculate this area. Now we can here, if you know something, we should multiply sure by minus. Minus as a plus minus, and also here minus as a plus minus. 3 minus 1 is 2. So its integral from 0 to 4 for 2 minus 2x exponential minus x plus 1. Here we can distribute this integral. So a is equal to integral 2 dx minus integral 2x exponential minus x plus 1 dx. Well, here sure it's 2x, we can write 2 outside. If you know something 2, we can write it also here outside. It's minus 2 integral x exponential minus x plus 1. But we have just proved this integral is equal to what? Minus x minus 1 exponential minus x plus 1 all plus k, where k belongs to r. So we can just replace this integral by its value. Well, what about this integral? 2 integral dx is equal to x. So it's 2x minus, we multiply this answer by 2 since we are having here 2 integral x exponential minus x plus 1. So we multiply our answer by 2, here it's plus k prime. Well, if we replace, it's from 0 to 4. Well, if we replace x by 4, we get it 8 plus 10 exponential minus 3 plus k prime. Minus for x equals 0, it will be 2a. Sure, minus k again. Plus k minus k is cancelled. Now we have a is equal 8 plus 10 exponential minus 3 minus 2e is approximately 3.06. Sure, it's unit square since we are talking about area. Thank you for watching. If you enjoyed this video, please like, share and subscribe for the continuity of our channel to support you by more and more information, with a great appreciation for your support.